Good evening, everyone, and welcome to the third Google Hangout in our Fall 2015 series. Tonight, we are talking about the power of big data and algorithms. And once again, we have a great panel joining us. We have Dr. Jingsong Cui, Vice President of Data Science at Nielsen. We have Joseph Michelli, CEO of Omniscient Analytics. And we have Dr. Thanos Gentimis, who is a professor of math and analytics here at Florida Polytechnic University. Guys, thank you so much for joining us tonight.
Thank you.
Yep.
We're talking about what appears to be a very complex topic. I know it is a very complex topic tonight, so I want to get the conversation started by just defining big data and algorithms for those in our audience who may not be familiar with those terms. So let's start with big data. And Thanos, I'm hoping you can help me out with this.
Okay, Crystal, remember last time you asked me that question, I promised you $1,000 if you give me a good definition. You haven't answered that yet. But in any case, when we talk about big data, what people think is something jumbled, something big. And people have come to use the 4 V's, so velocity, volume, variety, and veracity. Basically, you're looking at huge volumes of data that look different, okay, in type, and they come in fast, in terabytes per second or something like that, and you need to analyze them as soon as you get them, and you're not sure if they are correct, if they have problems, wrong entries in them, and you have to do all that as soon as you get it. Right, fellas?
Yeah. This is true. Right. The data needs to be in a form that is useful. You need to be able to identify what is actually conformed and what doesn't fit the conformity that you're looking for. But it's a large amount of data, and it can be of any type. In the pharmaceutical industry, I've dealt with some of the companies there, and it's high screening information. So they're looking at different compounds and molecules and how they interact with each other, and they do thousands of tests every day. Mm-hmm. And all of that data over time becomes this large collection of information that needs to be conformed and then analyzed in order to find if there's any hidden value in it. And big data can be that. It can be sensors on the streets. It can be visual information. Big data can be a lot of different things.
Yep. And also, kind of speaking from what we do at Nielsen, which focus on media consumptions, we see that every day. So nowadays, consumers are just overwhelmed with so much data everywhere in terms of what they watch, in terms of what they do online, even in terms of what they were exposed to when they go on the street. And we were seeing, data comes in every second, every millisecond, which provides a lot of challenges and opportunities for us to analyze.
So really what has led to this rise in big data as a field is our ability to collect so much information and put sensors on basically anything. Is that correct?
That is a good explanation of how we got here. In reality, it's been going on a lot longer than people realize. It had different names along the way. It was archiving, active archiving, smart archiving, which led to the big data story, which led to the definition, loose definition of big data, which became more and more information. And over the past few years, it's the Internet of Things, and it can be any kind of sensor data, any kind of structured data or unstructured data can be part of your big data lake, if you will. And so it's really grown quite a bit.
Great. And Jingsong, I know that your expertise is in a specific field called panel data. Will you talk a little bit about that and how it fits into big data?
Yeah, absolutely. It may sound a bit strange, how do panel data fit with big data? Actually, in a conference that we went to a couple of months ago, one of the questions coming from the audience is, how do you feel about use of panel data in today's world? And we think it's really relevant. Right? To give you an example, if you look at how TV data is collected, nowadays, many set-top box providers provide viewing data that collect through their set-top box devices that can give them, viewing data second by second on the millions of households they have. However, the one challenge in that industry is, how do you make sure your data can truly represent the whole population? Right? This is where Nielsen really has been focusing on for past decades. So we use our panel data that's designed through statistical method to be truly representative of the whole population. And we can use that data to really calibrate the big data that we get. So this speaks to the variety, one of the 4 V's that we talked about earlier. In some way, the big data gives you volume, but there could be biases that comes with it. However, through a use of panel data, you can get a true representative picture of the whole population and can use that to calibrate the big data to get a better view of the world. Another example is Facebook, right, which everybody knows. Facebook gives you tons of data about who is doing surfing online, who visits certain website. And the business is very concerned about the age and gender. That's very important for their business practice. But the information coming from the web surfing may not always be reliable. Right? You only know what cookie you have visited a website, but you don't really know is it the father or the daughter in the household. So what we can help to answer that question is, again, using our own panel, where we can truly measure the actual viewing of the web page, and that can be used to calibrate the big data to provide a more accurate view of the data. What do you guys think?
Yeah, I totally agree. And you mentioned at some point Facebook, and I also see a question. Sorry, Crystal, for jumping in, but I really like this question. I've actually kind of researched it earlier on. It says, how does Facebook algorithm determine my buying habits? That's a really cool question because, yes, they've put a lot of thought into it, and yes, it does use big data. To give you like a 3-letter answer is you're putting enough information up there to become a demographic. So then, if you're a demographic, ads are targeted. So some advertising company can set up a specific ad to say, for instance, I want to target people between 18 and 20, which are in college and have lots of friends and play basketball and things like that. So the more information that you put up there, the easier it is for you to be clustered and grouped with other people. And since people answer and click and do things on Facebook, you actually can measure how many people like that ad, whether or not it really targeted them, and then Facebook has its own algorithms to just throw that back to you. And also, it's your friends.
Yep.
Seriously, it is your friends.
That's very true. And let me kind of build on that a little bit. Because we are seeing changes and evolution in the industry. Used to be, companies can target consumers, reach out to who their target consumers in a very aggregate fashion. They may segment their consumers by age and gender, like where they live, for example, in the city or in the suburbs. But nowadays, the availability of data give them much more precise means to reach out to their target consumers. They can actually find out, what website the consumer has visited, how long has he spent on that website, as a way to better gauge their interest, to find out who really their target consumers. So this kind of is 2 issues. Obviously, privacy. Some people are maybe concerned about, am I sharing too much information on the website? But on the other hand, it also gives the companies a way to reach their consumers in a more precise fashion. And consumers may also be able to get information that they need in a much more customized fashion, instead of being overwhelmed by all these commercials that really don't seem relevant to them. I see pros and cons in both ways.
And a lot of this data that is available today, when you're using smart devices, when you are opting in on different things, you opt in on a mapping program. You opt in on some kind of game. In reality, you've opted in and said they could take some data from you. And if you really look, most of these things stay active for an extended period of time. That data is very useful because it can detect where you are, what kind of habits you have. It tracks that kind of information, and the marketers use that type of information so that if they know you go by a certain store all the time, they can start to put ads that would get you into a Walmart, for example. And I actually had someone ask me about that, because every time they drove past a certain point, they would get a note that popped up telling them about things at a certain store. So there was whatever they had subscribed to was actively watching their habits and developing an algorithm about that individual person, and then using that algorithm to promote things to them. And this is what's happening with this data, but it's also how the data is being collected. And so there's a plethora of information about consumers that isn't always from clicking on a website. It's just from your daily use of your smart device. It's really valuable.
So this probably comes to mind for a lot of people. When you first hear the term big data, I'm guessing that the Facebook question or any kind of online shopping question is the first thing to pop into everybody's mind. But there have got to be ways that big data is playing a role in our lives in everyday ways that we're not even aware of. What might some of those be? Joe?
Okay, I'm sorry. So could you ask that question again? I wasn't sure.
So Facebook is a somewhat familiar example of big data, but big data and algorithms are playing a role in everyday life that we may not be aware of. What are some ways or some influences of big data and algorithms that people might not be aware of?
Well, the simplest one is, of course, marketing, where you're getting, you buy a product and then all of a sudden you start to get, on Amazon, you start to get suggestions of similar things in a similar category. The best example is actually, and it's a story data analysts like to tell, is that Walmart was analyzing customer shopping, and over a period of time they could determine if someone was pregnant, and they would start to send them coupons for Pampers and things like that before they actually maybe told anyone, and so. This actually happened where people were going through a store and they got Pampers coupons because the daughter was pregnant and no one had known yet. So that's how it's being used. It's predicting things like that. It happens every day. In the tools you use, these development of algorithms that really can narrow down people's patterns so that marketing can really target in on what you're most likely to want, most likely to buy. That's the simple way of explaining it. There are much more intense ways that this kind of analytics is used, like companies using analytics to predict buying patterns on a global scale and planning production capacity based on that. So it's everything from the consumer marketing all the way up to industrial use. And the information is highly valuable in the right hands, and that's where data scientists come in. The data scientists find the hidden value.
That's right. I think that example that came to my mind about Walmart is they did some analytics around the sales and weather. And one of the interesting things that came out is before a storm comes, people seem to have a high demand for something like a strawberry lollipop or something. I forgot the exact thing because I don't usually buy it. It seems strange and people don't quite understand why. But what matters is it helps Walmart to identify opportunity to stock up the merchandise and obviously help them sell more stuff. But I think another example that really intrigued me is how much better the smartphones have got over the years. So it seems like mostly a hardware thing. But if you look at some of the functions, actually there is algorithms and data science going behind it. One example is how the voice recognition has been so much better over the years. I remember one of the older models of iPhone, when we first started Geary, it didn't really work well. But nowadays, I mean, there's still a lot of room for improvement. But it has got a lot better. It got a lot better of recognizing what you are saying. It also got a lot better to provide the right answer in a much faster manner. So all of this is, different deep learning, different algorithm working behind it that leads to this success.
Great.
And I want to also say that, when we're talking about algorithms being used in everyday life without knowing, the credit card fraud system is another big thing. Like, if you go 10 years ago, you would have a person going through your purchases and say, hey, you know what, this is probably wrong. Now I get phone calls if I get like a weird purchase somewhere immediately, because credit cards are now linked with these systems, and people can predict their buying patterns, and if something pops up, it's automatically shoots up an email or an alarm, and you get that response immediately. But if we want to move away from, the marketing and money and all that, there are a lot of algorithms being used out there. For instance, and that was the thing that we were discussing earlier, you could claim that the God particle, the Higgs boson, and for those of you that don't know what it is, it's like this particle that gives everybody mass. That was discovered in the Super Hadron Collider in Europe. That is also a product of some, highly specific analytic that crunched a large set of data. For example, the data that is being produced at the Hadron Collider, it takes them at about a week to analyze. So they always wait a week to figure out the details of whatever the experiment was. So you could argue that there are a lot of things that you could easily characterize as big data analytics that we don't really see it like that. But again, why is it big data important here? It is because without that vastness, without this complexity, you would just have a learning tool that doesn't have enough info to actually give you the right output, okay? And we reach states like, as it was mentioned earlier, deep learning. How does Siri know how to answer the question? Well, imagine millions of people making the similar request, and at some point the algorithm just learns what the right answer is by positive feedback. And the more positive and negative feedback you put into it, the better it becomes.
So, Thanos, just in that one answer that you gave, starting with the marketing element and talking a little bit about purchasing security, big data playing a role in that, and then going to the Higgs boson particle, I was thinking at every turn that you took that there are actually a great number of scientific industries that big data is impacting, from cybersecurity to various forms of engineering. And maybe you guys can talk a little bit about that. If somebody is interested in big data, what fields could they hope to be valuable in? And I'll start with you, Thanos.
Well, I mean, it's anything basically. Like, as long as you understand, as long as you be able to learn and address one problem, let's say in engineering, then you can use the same type of mentality, the same tools, and tweak them to the specific problem that you're trying to face. For instance, in the big data lab here, we have people working on, I don't know, stocks, and other people are doing sentiment analysis. Some other folks are doing geolocated Twitter data. And it doesn't matter, because the patterns, the tools, the analytics kind of look the same. And when people get that idea, when they understand it once, they understand everything. Okay, and then you could be impacting everybody, every field, basically using the knowledge that you acquired in this field and just slightly moving that towards the appropriate setting. And I think Joe, you have more knowledge about that, right?
Well, I agree with you, but I think an important thing for data scientists to recognize if you go into that field is that you really need to understand the field you're in when you get there. You need that underlying information, knowing how to analyze data, how to build your algorithms, but you also need subject matter expertise, and that makes all the difference in the world in industry. Sure. Because while you, and it's very true that it's transportable. You can take a data scientist who works in bioinformatics and take them into an industrial environment and hand them the data and tell them what you want to do with the data, and they could massage that data. They could create algorithms that would give you your results. But the difference that I see in business is that data scientist who actually understands the manufacturing process has a little bit advantage over the one that doesn't, because they know exactly what the end result has to be. And one of the big issues in industry today is the translation issue. The translation issue from the line of business person to the person who actually understands data analytics. The line of business person has a different vocabulary than the data analytic person. And it's bridging that gap. So the more you understand about the industry you're in, or the data you're working with, the more valuable you become.
No, we have a great question from one of our viewers that I think relates to this. So from Jeffrey Dubois, he asks, is there enough money to be saved or made in the analytics of the data from a small business to warrant that business to hire a data analyst, or should the business of data analysis be left to large corporations? Joe, you're smiling, so please chime in.
Well, you know, small business has been doing data analytics forever, because a small businessman is looking at his sales from last year, deciding what he's going to order for inventory, etc. So the question about whether they need a data analyst is kind of a double-edged sword. No, they don't need a data analyst if they're truly a small business. But if it's a small to medium business that can afford employees and has more than X number of employees, let's say it's a $10 million company, then absolutely they should have a data scientist. If it's the mom and pop grocery store, then someone should learn how to use the analytics that are available to them. The reality is, you get to a certain level where they can actually afford that employee, it's impossible to be competitive without data analytics today. Your competitors are using it, and that's really where it starts. I'm sorry, go ahead.
No, I just want to say I agree. And I would also think that, you know, for mom and pop shops who cannot afford a full-time employees to do analytics for them, there are actually a lot of free tools out there. You know, I think you know, they can go to, for example, Google Analytics or even Facebook, who provide actually a lot of free analytics tools to help small business. I think in today's business world, nobody can afford to do work without using the data to help them.
Now, I have another question from a viewer that may help to inform this discussion from Bob Morgan. Oh, I'm sorry, and it's not from Bob Morgan. Sorry, Bob, we'll get to your question. The question is from Facebook, I believe. What does a data scientist do? And I want to modify this a little bit because you guys have been using two terms interchangeably, possibly data analyst and data scientist. Are they the same thing, or are we talking about two different careers?
Yeah, I guess the same thing. I may have been using it interchangeably. I would like to say yes. Maybe there are some small differences, but for the purpose of this conversation, we can say it's the same thing. And if I may, I can answer a few things because I consider myself a data scientist. So what I do most of the time is I play around, clean my data. After I have come up with a nice question, I gather the relevant information. I research the literature a little bit, try to figure out what other people did in similar situations. I use math to model things or make some hypotheses and test them. I have kind of moved away from statistics, but they always jump back in, so you have to be able to know and be able to employ them. And there's a lot of data manipulation. Ultimately, you have to write your codes. Okay. If you use one of those packages that are out there, you'll notice that at some point there is this thing that they can't do, so you'll have to do that. And then you have to be able to communicate that, as Joe said, to the people that are actually going to be using that data. So there's some sort of presentation, analytics, visualization, writing. And at the very end, of course, you have to test. Whatever you have decided is the answer, you have to test it. Okay, so yeah, then you go back to the drawing board and create your tests, and gather more data until it actually works. So that is what a big data, a data analyst does, if I'm talking from experience.
Jing-Sung Cho, would you have anything to add to that?
I mostly agree, and I think maybe like you know, if you look at one company for another, there could be, you know, small differentiations. I think maybe tend to be like in bigger companies when they are more organized structure, you may have you know, better, more defined functions, versus in, you know, smaller companies, you know, the same. One person may do all kinds of job. But either way, I feel like everybody needs to have the skill to work with the data, to do analytics. And the tool you use, the knowledge you have may be different based upon your functions. Some folks may be more towards the business end, like Joe was saying earlier. Others may be more kind of technical, doing programming, doing algorithm, doing pure data work. But they're all working with the data. And I think ideal data scientists should have all these skills. So we kind of think of there are three essential skills that a data science needs to have. He needs to have some understanding about statistics, right? So this is where we also kind of see a lot of strong data scientists with very kind of strong training in statistics. I think what that gives you is a good understanding to phrase a problem, whether it's a business problem or data problem. And we also need people who have strong programming skills because, with the big data, with the scale that we're working with, you can no longer use a punch card or scratch pad. You have to rely upon, good computer and tools to help you analyze the data, right? And the last, we obviously also need business knowledge as well. So this is where kind of more like analyst kind of work that kind of gap the distance between technical skills and client and industry domain knowledge. So I think a good data scientist needs to have all these three skills.
That is great advice, Jing-Song, and I know that a lot of our viewers are students who may be interested in STEM and are exploring the topic, so I know that's especially good advice for them. And with that, I am going to take this opportunity to answer Bob's question now. Bob Morgan asks, what projects in big data are students working on? And Thanos, I'm going to toss this to you to talk about what students are doing here at Florida Poly, and hopefully that'll answer some questions from students watching about the things that we're doing in our classrooms, the degree programs that you can pursue here if you're interested in big data.
Yes, so let's say in the lab now we have various groups. The thing that I like the most and the thing that is really tied with big data is sentiment analysis. Basically, description is very fast. You download Twitter data or some other feedback from, like, I don't know, some social media, and then you're trying to figure out whether or not the object, the hashtag that you've used to find it, has a positive or negative effect on people. And you're really teaching the computer to understand right from wrong or positive from negative. And we have the students working on free online software, like they're using Python-based codes to download the data, store it, clean it up, train the NLTK, and it's a packet that trains the computer on what's right and what's wrong, and then at the end give a nice presentation of whether, let's say, people like Florida Poly or don't. They actually do, by the way. And things like that. The other one was how does one do, as I said, figure out the stock market, do short-term predictions based on exchanges that happen every day. How does one cluster stocks based on data sets like the prices for the past, if I remember correctly, 45 years. And so the students, again, were able to employ free online software to do that. And that's only what they are doing in the lab. I know there are a lot of classes here, databases and introduction to programming. Later on we have specific for big data classes, which will lead to projects that are in deep learning and machine learning. We also have good connections with the IBM, and we have a supercomputer here, the IBM supercomputer. And we are thinking about employing our own version of the Watson machine, so basically teach some of our computers to think a little bit and make some predictions. And I'm also interested in speech recognition, pattern recognition, and vision. And we have other labs like the VTC lab and some other professors that we just hired that are really interested. I heard of a project which is teaching the computer to understand sign language and automatically translate to sign language. So, all these things, all these projects are starting up right now, and we're looking for interested students that will dive in and start immediately. By the way, they can start day one, and I'm not kidding here. All the students that I had in the lab last semester were freshmen or maybe the second year, and that's it, because we just started. So it's not hard to dive into it. You can just come in here and get involved in the project, learn while you're doing your other classes, and ultimately get into the system.
That is awesome. I'm going to take a moment to also let people who are interested know that you can find more information about our programs at flpoly.org, and you can also request info at flpoly.org if you'd like to learn more. And Thanos, your talk about Watson, the supercomputer. If people don't know who Watson is or what Watson is, he was made famous, I think, on Jeopardy several years ago as a computer that could actually answer questions and understand context. And as I was reading articles and giving myself a crash course in preparation for this complex topic, one of the things that I read that was fascinating and related to this is an example of Wimbledon using sensors on their tennis courts to track the speed of hits or the force of hits and every bit of data about a game, and the sensors turning that information into tweets and even small news stories. So again, things in context and almost thinking like a writer or a journalist. That sounds like big data and algorithms can get really close to artificial intelligence, AI. What do you guys think about that? Is that where we're headed with this? And Joe, do you want to chime in?
Sure. I certainly believe artificial intelligence is where we're headed, but I also have a different definition, I think, than the traditional one. Many people think artificial intelligence is that entity in the corner that can act like a human. In reality, artificial intelligence is that slice of what we can do, and doing it very well. And that's what Watson does. Watson does some pretty incredible things with understanding context. It uses a lot of power to analyze the information and give you answers that are relevant to what your question was, and it's a very powerful tool in that sense. I think that all of analytics is headed towards what we would call AI or deep learning. It's just natural. It's inevitable. And the fact that we can process this information, I've been doing AI for longer than I care to admit. And AI in the old days was truly very difficult because of the limitations of memory and the limitations of computer speed. With the speeds we have today, and the amount of information we can use, and the application of big data, it's just inevitable that we're going to be able to make better decision-making machines. And those machines become more and more capable of making what seem like human decisions. And Watson certainly is one of the best examples we have that the public knows about. But there are a lot more machines behind the scenes that are smarter than Watson, that are making decisions every day. And American Express is a great example. They've had an AI machine that's been improving and learning for over 30 years now, making decisions on how you purchase to determine whether there's fraud, determine whether you're going to go over your credit, what they consider your credit ceiling, and you'll get a phone call. All of these things are based on AI algorithms. And so, yes, I believe it's already there. It's really happening on a very fast pace. And certainly the stuff that's going on with vocal recognition or voice recognition or even text recognition has AI behind it.
Hey, Joe. Actually, I want to ask you a question. Please, tap into your expertise in artificial intelligence. I think right now in the industry there are actually some debate ongoing, almost like two camps. I think obviously a lot of people can see and agree on the benefit that AI has brought us, but there's also several people, actually some of them are pretty well-known industry and academic people who are concerned about, possible effect of AI can bring us, right? The extreme example could be, like Terminator as a from the movie, right? I want to see what you think about that, given what you work on.
Well, so I honestly can say that AI needs to be controlled, and because we can't really trust the machine. We can't really trust the machine. So if we ever get to that point where we've made these things smart enough to take that kind of control, I hope we've built in the safeguards Because if you think analytically, and you think logically, and you take a machine that runs, like most of these movies go, runs our Defense Department, and you look at what's happening in the world, the machine is going to make a decision we won't agree with, because the logical decision may be do something. So I think that it's very true that we need to we need some common sense around the way we use AI, and even at a much more real level. Artificial intelligence is certainly a part of self-driving cars.
Yeah.
So
Fascinating.
now you have to think about that. How do you build walls around what that car can and can't do? And also we need to think about AI as a component to prevent hacking into those cars.
Right.
Yeah, that's right. Thank you.
And it's great that you touched on that, Joe. Our last Google Hangout was about autonomous vehicles, and we didn't even I think scratch the surface of all of the AI components of what that means. So if people are interested more in autonomous vehicles, we have a Hangout that you can watch on YouTube about that. There was another quote that I picked up in my crash course and my research before this that I think is tying into this, and it's from Peter Sondergaard, who's the head of research and IT at Gartner. And in this article, he said by 2020, 40% of interactions will be with smart agents. Siri, Cortana, Echo, Google Now, these are all the early prototypes, and agents will become the platforms of the future. In fact, he goes on to say that users will forget apps. We're moving into the post-app economy. I mean, that sounds like what you were talking about, Joe. How much of this is getting really close to AI, and how much of it is dependent on algorithms and is Watson-like, basically?
This is not a commercial, but that's what our application is. Our application eliminates the interface, that traditional interface. Instead, you're having a textual conversation with an artificial intelligence component that is then creating analytics for you. I think that there are a lot of tools out there already. There's some tools out there for setting appointments, where you actually email this virtual assistant, this AI-based virtual assistant, and it can figure out everyone's time schedule and make suggestions autonomously. So we are there. It's starting to happen, and I think that we may not realize it, but it's a lot of these little apps are already evolving into that. And I think that revolution is going to accelerate very quickly in the next 2 to 3 years.
And Joe, if you let me chime in, the reason why it actually works is because there are millions of us using the same apps, doing the same things, putting feedback back. So basically, like, if Siri finds what I wanted it to find, I'm happy and whatnot, and people know about it. Otherwise, you give it a no, that was not right. So they learn. That's the thing. It becomes more and more real because big data, again, it's behind it. Imagine having like 3 users only. You cannot really teach, the right thing with only 3 users. Imagine now 3 million users doing the same things every day. Some of them get the right answers, some of them don't. The program learns, cumulatively, and at the end, seems like it just understands like a human being. So again, big data is hitting in the back. That's why all these things become better. It's because there are a lot of users in it.
Yeah, that's exactly right. That logic is being created by every user. Those decision trees are created. Those percentage of confidence in making a certain choice is exactly what you've said. It's true.
Thanks, you guys. I'm seeing some of the questions start to pour in from this conversation, and one is from it sounds like a student who's applied to Florida Poly and is really excited with. I'm going to go ahead and answer this question because I love it, and I think maybe a lot of people will have something similar. He asks, Matt Santella asks, would Florida Polytechnic work with Google to allow its AI students to experiment with autonomous driving? Matt, we are currently working with Google. They're not one of our partners, but I wanted to let you know that one of the things we do is work directly with industry, and industry has the opportunity to bring problems to Florida Poly, and students have the opportunity to work with faculty in solving those problems in the classroom. And that's part of our learning experience here, is that it's a hands-on learning experience where you get to work on real-world problems. And Thanos, I don't know if you have anything that you want to add to that. And Joe, Jingsong, feel free to chime in as representatives from industry on how important it is for students to get this hands-on experience.
Yeah, we have classes here, Design 1, 2, and 3, which are basically projects that come in from our partners. And, you know, our students work on those projects for credit. They get to discuss with the partners. They are really the experts on this, and their grade is dependent on that. And those projects don't start, you know, at the 4th or 5th semester. They start as early as the 2nd if you wanted to, maybe the 3rd, where, you know, we actually are now running the pilot, and it's going really good. And it's all sorts of projects from engineering, computer science. We're expanding to everything. We do have a forum for that, which you can find also on our website. What happens is, really, the students are presented with a real-life problem, and they're left to figure out how to do it, of course, with the help of the professors. So I'm not sure if we're going to be working on the autonomous driving, but we have a lot of other cool projects running at this right now. So yes, we are really keying on the partnership. We enjoy our, you know, being able to work with our partners. I've visited Nilsson. We've been working with you guys on a project. We've been working with Curtis Wright and some other people, both through internships and also with this Design 1 project. And that goes on Design 1, 2, and 3. So you'll have that for like almost a year and a half of just working on a project with the partner.
Yeah, I was going to mention that too. At Nielsen, we also focus a lot on collaboration with academics. Even though we don't have cars, you know, that's not our business. We do have a lot of engineers, a lot of them based in Florida, who looks into designing the next generation devices to help us better monitor and collect better data. So, you know, a lot of them are like smart sensor based, you know, smart devices. It's really cool.
And it's really one of the advantages of Polytech. It's really one of the things that drew us to come and start working with Polytech was the fact that students were getting real world experience, and we were able to work with students. When it's time for these people to come out into the workplace, they have a leg up over someone who's just had an academic background. As you actually students who come out of Polytech will understand problem solving, and that's the critical part that they learn in these programs.
Problem solving is a huge emphasis in everything we do. We have another question from a student, and I definitely want to get to these. Dylan Bent says, I'm a high school senior and am curious if a computer engineering major can design the sensors and algorithms necessary for acquiring and analyzing big data. And you know, as I was reading and as I've been listening to you guys speak, it struck me too that really big data sounds like it's crossing a lot of disciplines. You guys have to know not only what data to collect, but also how to collect it, and that's where you're getting into the sensors and the materials that you're using. So how does that play in? Do other disciplines have an opportunity to play a role in big data, like computer engineering?
Oh yeah, absolutely, yeah. I mean, right now we have started a project, as I said, with the VTC lab, where they're creating small platforms of smart sensors. So we haven't been talking too much about the parallelization of those algorithms. So since the data is so big, you can't really have a central computer churning it all the time. What you need is some of the assessment, some of the analysis, some of the cleanup to happen, let's say, on site, on the node, on the sensor. So you really need the computer engineer to come in and say, here's a hardware solution to your software problem. Instead of sending you like this huge long signal, how about I trim it down into the important stuff? For instance, I can only send a yes or no to, is this working, is it hot, is it not hot? So then, of course, you need the computer engineer to come in and say, instead of sending the whole signal, I will design and put some smart, you know, algorithms and hardware on the sensor to send only the needed stuff in a format that the central processor can take and, you know, analyze fast. So yes, both the sensors, also the architecture, the parallelization of such computers is a big thing. I admit I know nothing about that, and I'm glad that we have knowledgeable people here, because I would run into a wall immediately. So you need people to be able to design the system for which you will apply your algorithms. And I'm seeing Joe over there goes like, yeah, right. Exactly, right.
Yeah. Well, certainly. At the end of the day, a lot of people can operate with the programming. They understand the application layer. Computer engineering gets you deeper, and we're not done with developing new systems. Right. We're not done with developing intelligence. Watson, going back to it, is massively parallel. And I think there are a lot of innovations in parallelization that haven't happened yet. And it doesn't necessarily mean that the future is completely at the software level. Because as new materials are developed, as new technologies, as nanotechnology really becomes more viable, there's a lot of work in computer engineering that will benefit big data, analytics, and the future of AI.
So we've talked about so many exciting things, from marketing to AI to the Internet of Things, and so I'm noticing that some of our viewers have the obvious question: well, cool, how can I discover an algorithm? How does somebody go about discovering an algorithm that does everything that we've talked about? And Jeffrey Dubois specifically is asking, how does a data analyst know when a data set is worth investigating when we are surrounded by useful data to analyze? And Jing-Song, maybe you can start this off, but I know you all have something to chime in here.
Yeah, sure. First of all, go to a good school. I think the good thing is that this is really a field that you can get first personal experience. You can get your hands on the data to really kind of play with it, get a feeling. Like it's not very theoretical, abstract. So that I think, to me, that makes it a more exciting field. And I think you will get really learning a lot through a good program that has emphasis on these trainings. And I think once you took a few courses, you will get a lot of better ideas about how to get started. For example, like for us, our typical data scientists tend to have a master's degree in one or a couple of fields: statistics, data science, or even computer science. So that's kind of how we look for our people.
Thanks, Jing-Song. Thanos, Joe?
Yeah, so for the data scientist, first of all, to answer the question, how do you find the useful thing to analyze? If you find that, let me know. We will start a company. No, really, what happens is you get experience, as Jing-Song said. You have to get your hands dirty with data at some point. You have to figure out, analytics, types of analytics that you applied in something else. Try to be able to figure out, okay, I solved this way, I made this hypothesis, it worked, therefore I'm going to use something similar. But also, going back to what Joe said, you really need to be able to communicate with subject matter experts. So the data analyst is actually not the first person to instigate the question. So what you really need is you need someone to come in with an interesting question, an interesting data set, and say, hey, I have this idea. Could you work it out for me? That's really what the data scientist does. Now, if you have the extra knowledge of a certain field, then you excel. So my advice is, not just go to a good school. Go to Florida Polytechnic. That's a good school. And start getting your hands dirty. Learn a bunch of techniques. Learn a bunch of ideas. And also connect with people, connect with companies, learn what's important out there, and try to mimic, try to reuse things that you learned into different fields. At some point, the experienced analyst figures out solutions on the fly, like looks at the data set and says, oh, I think I should be doing this. And at the end, whatever comes out is easy to translate to the subject matter expert. So I think that's what you're supposed to do in general if you want to dive into this field. And it really doesn't matter what's your background. As long as you're willing to get your hands dirty, learn the basics, modeling, math, statistics, and all that, you should be able to do it. And my AI turns off the phone, the lights all the time. Excuse me.
Cue the lights. While we're waiting for Thanos to return, one of the questions that's related to this from Jordan Green is there a best programming language to use when gathering data and identifying these key data points? Jing-Song, I don't know if you have an answer to this or.
That has a lot to do with personal preference and which field they come from. In what we do, we see a lot of people choose one of the three tools. SAS, who is more like a traditional tool used, it's still very popular. But nowadays, we also see a lot more people using one of those two open source programs like Python or like R. And I think there's no wrong choice between the two. And also, you can play a little bit, see what your friends use, what your professors use, and both of them are excellent choices.
And and really Python and R have become so widespread, and they certainly are a good place to start. But it is a personal preference. There are a lot of tools out there. There are a lot of add-ons that add a lot of value to other languages. So you really need to kind of experiment and explore. There are so many things you can add on to Python, but there are also a lot of things you can add on to C# or one of the other variants. There are things out there. So get your hands dirty, try it out, see what like Jin-Song said, see what other people are doing, and use it. And there's some great packages out there that are in the public domain that you can use that are get into the application and start using. There's one that we've used a lot, which is called Orange, and it is a free open source. It was actually developed for bioinformatics, but it has so much value in it, and you can write Python scripts for it as well. So it really is one of those tools that we like. When people ask us that question, what should I do? We point them to Orange as a way of just getting your feet wet. And certainly the high school students that are on this call here asking this type of question, it's absolutely the languages that are easiest to learn are Python and R, and then all these other variants are out there.
I agree, and those are the two languages that we start off people in the lab. So we are teaching, we have like mini sessions. Of course, we have a class on R, but even if you haven't had that, you have a class on Python, but even if you hadn't had that, we have, mini lectures on both Python and R and relevant toolkits for those. I want to say also SPSS is a good package. Of course, it's a little bit expensive. MATLAB has a lot of functionality, and we saw some of their applications lately. SAS is really, really good for some applications. Of course, you need to know also databases. So maybe something like SQL or MongoDB or the new things that are coming up there, Apache, Hadoop, and all that. But really, as my fellow panelists said, it's a matter of preference. I want to say that Python is very easy to learn how to do the first few scripts, and R is very intuitive. You can just do a couple of things with small data sets and you will get the hang of it. So if you're I don't know, a high school student that can't afford, let's say, an SPSS package, start with R. There's a lot of documentation, maybe like 10 years of documentation for R out there that will help.
We are running out of time. We're almost to the end of our hour, and it's been such a great discussion, and we still have questions pouring in. So, folks, if we didn't get to your question, what we always try to do is post a blog after the Hangout and answer some of the questions that we weren't able to get to, so we'll try to answer them there. I want to thank all of our panelists. You guys were fantastic, and it was such a great discussion. In fact, I was making notes as we were talking. It sounds like a lot of the things that we dove into and touched lightly on could be Hangout topics of their own, from AI to the Internet of Things. So I'm going to ask actually our viewers, if there's something that really piqued your interest here and you want us to do a whole Hangout about it, tweet us using the hashtag STEMTalks. And finally, this is our third Hangout of the fall 2015 semester of 4. Our final Hangout will be on November 12th at 7 p.m. and it is going to be an Ask Me Anything style Hangout with Dell Chief Information Officer Jim Steichleather, who is a great speaker. So please join us for that, and we'll also see you in the spring. Thank you so much, everyone.
Thank you.
Thank you.